So here we are. Now, my equation is x squared plus 2x minus 1. So for it, if I want to know f of x plus h, again, I'm going to plug in x plus h everywhere I have an x here. So I've got f prime of x equals to the limit as h approaches 0 of, and it's going to be x plus h quantity squared plus 2 times x plus h minus 1. All right, so all of this right here is f of x plus h. So now I'm going to subtract from it f of x. And f of x is just simply what the original equation was. X squared plus 2x minus 1. And it's all over h. All right. So the arithmetic's going to get just a little bit complicated here. Not necessarily complicated, but it's going to be important that you take your time and get each one of these steps correct. All right, x plus h if you square it. Again, it's a binomial squared. So it's x squared plus 2xh plus h squared. All right, now we have 2x at x plus h, so just distribute here. So plus 2x plus 2h, and then minus 1. And now I'm going to distribute the negative into this, so it's minus x squared minus 2x and plus 1, and again it's all over h. So f prime of x is going to be the limit as h approaches 0 of. Now, on this step right here, when you're dealing with polynomials, there's going to be a neat thing that's going to happen. If the term does not have an h in it, it's going to go away. Now, if it doesn't go away, then I've done something wrong. So it's kind of a checking point right here. All right, so I've got an x squared, and I've got a negative x squared, so they go away. I've got a 2x, and I have a minus 2x. And then I have a negative 1, and I have a positive 1. So, from that, what am I left with? Every term has an h in common, right? H, h, and h. So, let's factor an h out of everything. All right, if I pull out an h, I've got h times 2x. All right, h from h squared is what? H. And then h from 2h is just 2. Okay. Again, that's all over h. Well, what happens at that step? The h's go and play with the dodo birds, don't they? So we're left with f prime of x equaling to, if I plug in 0 right here, I've got 2x plus 2. So that's the overall derivative. It's the general derivative for this equation. So that's my derivative of this equation. Now, I want to know what's the slope at the point 534. Well, so f prime of x at 534 is 2 times 5 plus 2, which is 12. So it's pretty steep right there. It's got a slope of 12. A rise over run of 12 at that point, that's a really steep tangent line. So that is my solution for that point. Again, you can pick any x value, figure out the point that goes with it, and you wouldn't have to go through all of this again. You could just figure out the slope at any point on that curve right there by plugging in right here. Yes?
What happened to the h on right before you got the 2x plus 2? What happened to it?
All right, this is h is approaching 0 right here. So basically what's happening here, let me do this. I'm going to make it 2x plus 0 plus 2. So it goes away and just becomes 2x plus 2. Great question. Sorry I wasn't clear on that earlier. I'm going to go ahead and stop the video.